In this video, we are going to discuss the concept of parallel and perpendicular lines. Basically, we'll be looking at their gradients. What's the relationship between the gradient of parallel lines or the gradient of perpendicular lines? But before we start our discussion, let's first begin at how can you find the gradient when you are given just the equation of a straight line. Now, given the equation of a straight line, you must first ensure that the equation is written in the form y is equals to mx plus c, whereby m is the gradient and then c is the y-intercept. M it's the gradient and then c it's actually the y-intercept. So in other words, the coefficient of x, this number there, will give you your gradient. Same applies to c, which is going to give you the y-intercept. Now, let's just try an example to try and conceptualize this idea. Number one, you are given the equation y is equals to your negative 2x plus 3. What's the coefficient of x in this case? Coefficient of x is the gradient, and then it's equals to your negative 2. And then what's the value of c, which is going to give you the y-intercept? So the y-intercept is 3, and then as a coordinate, it can be written as 0, 3. Check for this equation. Now, one thing you should notice for this equation is that this equation, it's not in the form y is equals to mx plus c. So the first thing to do is first to make sure that the equation is in the form y is equals to mx plus c. How do we get that? By making y the subject. How do we make y the subject in this one? Since we have a minus 5y here, since we have a minus 5y here, we need to transpose this number to the other side of the equation, like that. Or simply, since it's minus 5y, we can just say plus 5y on both sides of the equation. And then if we do that, this one now it's going to go away, and then you'll be left with 0 there. And then you have your negative 5y being equals to negative 5y. It's now equals to your 2x plus 1. Divide each term of the equation by 5. You are getting that y is actually equals to negative 2 over 5x plus 1. It's actually minus 1 over 5. Now, what's the gradient and the y-intercept here now? The gradient is the coefficient of x, and then this is the coefficient of x here. This one, that's your gradient. And then this one is your y-intercept. This is the y-intercept. This one is your gradient. So what's the gradient here? M, which is the gradient, is negative 2 on 5. And then what's the y-intercept? Y-intercept, this is nothing but negative 1 over 5. As a coordinate, it can be written as 0, 1 over 5. Next question, we have y being equals to 3x minus 4. What's the coefficient of x in this case? Coefficient of x is this one, the number placed before x and multiplying x. What's that number? That number in our case is 3. So the gradient for this line, m, is equals to 3. About the y-intercept, the y-intercept is actually equals to 4, and then there's a coordinate that can be written at 0, 4. Our other example here, does this assume y equals to mx plus c? No. How do we get y equals to mx plus c? make y the subject first. So making y the subject requires us to first remove this guy from this side and then try to transpose it to the other side like that. So if it jumps to the other side, it's going to be a negative. So you're actually having a 2y being equals to -3 negative x minus 3. Dividing each term by 2, you are getting that the y is now equals to -1 on 2x minus 3 on 2. Now, what's the gradient from this line? The gradient m is equals to -1 on 2, and then the y-intercept. What's the y-intercept? The y-intercept in our case, it's just -3 over 2, and then as a coordinate that can be written as 0, -3 over 2. Hope you actually find the idea around this concept. So to find the gradient from an equation, you are just going to first make the equation to be of the form y is equals to your mx plus c. And then your gradient from that equation, it's going to be the number placed before x, which is m. That will give you your gradient. And then c, this is nothing but the y-intercept. And then it can be written as a coordinate as 0, c. Let's move on to the idea of parallel lines. How can you define parallel lines? Now, parallel lines, these are straight lines that are in the same plane that will never meet, no matter how long you extend them. If you have two lines that never meet, no matter how far they are extended, those two lines deserve to be called parallel lines. For example, these lines here, which is the railway lines, they are always equidistant from one another, no matter how you try to extend them. This line is just parallel to this one. They can never meet. Similarly, these two lines, this one is parallel to this one. No matter how you can try to extend this line, they will never meet. Now let's talk about their gradients. Now, if two lines are parallel to each other, they will have the same gradient. Let's just look at this following illustration here. We have this red line here, and then its gradient is your 1 over 2. If you can recall well, gradient, it's rise over run. And then if the rise is 2, and the run is 4. So the gradient is actually 2 on 4, which can be simplified to 1 over 2. Let's also check the blue line here. The blue line also have a gradient of 1 over 2 because its rise is 2 and its run is 4. So 2 and 4, it simplifies to 1. So two lines, once they are parallel to each other, they will have the same gradient. Let's check the following examples. For your A, the question says write the gradient of the line parallel to this one. So first things first, we are first going to extract the gradient, and then the gradient of this line is -2, because -2 is actually the coefficient of x. So the gradient of the line parallel to that is going to be, so the gradient of the parallel line is going to be, what's the gradient of the parallel line to that? It's going to be the same gradient as the given. So the gradient is just -2. Let's check this one. For this line, we cannot directly extract the gradient because this equation does not say y is equals to mx plus c. So first things first, we need to make y the subject. So in making y the subject, we need to first subtract x on both sides of the equation and also add 3 on both sides of the equation. So what will happen here is that x will be cancelled and the negative 3 will also be cancelled. And then on your left hand side, you will be left with 2y being equals to negative x plus 3. And then if you divide each term of this equation by 2, you are getting that y is actually equals to negative 1 over 2 x plus 3 over 2. Now let's extract the gradient of this line. So the gradient of this line is actually this number here that is just placed before x. So the gradient of the line parallel to this one, it's actually going to be the gradient of the same line. So it's going to be the gradient is nothing but negative 1 over 2. That's the gradient. Now our next task is now to find the equation. So now we are going to find the equation of the line parallel to this one. First things first, negative 4 is actually the gradient of this line. So the gradient of a line parallel to that, it's actually equals to 4. And then the point for this line is 1, 7. So let's calculate the equation of a line passing through 1, 7 with a gradient of 4. Just recall from our previous video when we calculated the equation of a line, you said you can use 2 methods. The first one being y equals to your mx plus c, whereby you substitute y, m, and x to find c, then resubstitute m and c to find the equation. The other one was just use y minus y1 equals to m into x minus x1. Then in that equation you substitute your y1, your m, and x1, and then try to simplify that equation. You'll find the equation of the line. Let's try to use the second method, which was y minus y1 being equals to the m into the x minus x1. If you happen to haven't seen this, feel free to go into our previous episode to just check how this is done. Now let's do the substitution here. So your y1 is actually the y coordinate from the given coordinate. So from the given coordinate y it's 7. This is equals to the gradient, it's 4, into x minus x1 is actually the x coordinate in the given coordinate, that's 1. Now from there we have y being equals to the 4x minus 4. If we transpose the 7 to the other side, we are going to get a positive 7. And then this is now giving me y is actually equals to 4x plus 3. Let's find the solution for the next. In this case, you are given 2x minus 3y plus 5 equals to 0. First things first, we need to extract the gradient from this line. Feel free to pause the video and extract the gradient at your own. So first things first, let's just transpose this one here, the negative 3y to the other side. Then you will have 3y. Remember, when you transpose it, it changes its sign. So it's 3y equals to what was left is 2x and positive 5. Then dividing each term by 3, you are getting that your y is actually equals to 2 on 3 x, and then that's a plus 5 on 3. Then the gradient for this line, it's now 2 over 3. So the gradient of the line parallel to that, it's the same as the gradient of this one. So the gradient of the parallel line is just 2 on 3. And this line is passing through the point 3, comma, negative 1. Now, let's find the equation. Let's use method 1, which was y being equals to mx plus c. Substitution, value of y, it's negative 1. It's equals to m, which is our gradient, 2 over 3. And then x is 3. And then this one is a plus c. And then let's try to simplify here. This one is negative 1 being equal to 2 on 3 times 3 is actually giving me positive 2 plus c. And then from there, let's subtract 2 from both sides. You're getting negative 1 minus 2 equals to c, which simply means that your c is now actually equals to a negative 3. Now let's substitute back the m and the c to find the equation. So our equation is going to be y is equals to 2 on 3 x minus 3. Now I just want us to confirm if really these two lines are indeed parallel to each other. So we are going to draw this line and this line on our GeoGebra. Then we will confirm if they are really parallel to each other. Let's go to GeoGebra. Now we are here on GeoGebra. The first line had an equation y equals to 4x minus 1. Let's plot just that. Y equals to 4x minus 1. That's the equation there. Let's draw the other one, the equation of the line now parallel to this one. It's 4x plus 3. Y is equals to 4x plus 3. Y being equals to 4x plus 3. That's the equation. And indeed, these two lines are equidistant from each other, and no matter where they can be extended, they will never meet with each other, which indeed shows us that these two lines are actually parallel to each other. When we say two lines are perpendicular to each other, we actually mean that they meet at 90 degrees. Now, for example, you have crossroads here. Let's just check something here. This meets at 90 degrees with this one. Same applies to this one on my left. Here we having a 90 degrees where these lines are meeting. So we say such lines are perpendicular to each other. Now, here is an important fact about two perpendicular lines. If two lines are perpendicular to each other, the products of their gradients will be negative 1. If two lines are perpendicular to each other, the product, their gradient, is negative 1. So let's move on to examples on this concept. Write down the gradient of a line perpendicular to the line with the gradient of 1. In other words, what number can be multiplied by 1 to get negative 1? The answer is negative 1. Number B. What is the gradient of the line perpendicular to 2? In other words, what number can I multiply 2 with to get negative 1? And then just recall that 2 can be written as 2 over 1. And then what's the reciprocal of 2 over 1? It's 1 over 2. And again, remember to change the sign, and then that will give you a negative 1 over 2. So the gradient of the line perpendicular to a line with the gradient of 2 is gradient negative 1 and 2. Next question number C. What's the gradient? What number can be multiplied by negative 3 on 4 to get 1? That's the negative reciprocal of that. Now the negative reciprocal of 3 on 4 is positive 4 on 3. Next question, 7 on 2. The gradient of the line perpendicular to 7 on 2 is the negative reciprocal of that. The negative of 7 of 2 of the reciprocal of 2 over 7 is actually negative 7 over 2. So basically, to find the gradient, you just flip and change the sign. Now let's go to number B. For number B, you are required to calculate the equation of the line perpendicular to y equals to negative x plus 6 and passing through for negative 1. Then the gradient of this line now is the coefficient of x, and then the coefficient of x is negative 1. And then what number do I need to multiply negative 1 with to get 1? So the gradient of the line perpendicular to that is 1. So now we are having a gradient of 1 and a coordinate of negative 4, 1. Let's find the equation for this one. Y minus y1 is equal to m into x minus x1. Let's substitute. So substituting into this one is y minus y1 is 1. This is equals to the gradient, it's 1 into x minus negative 4. And then let's simplify here. So the y will be equals to, remember, we're transposing the negative 1 on the left hand side to get x plus 4. And then there is the plus 1. And then now the equation will be y equals to x plus 5. Let's check for this one. Now this one is not in the form. Y is equals to mx plus c. So first things first, we need to write it in the form y is equals to your mx plus c. If we take this guy to the other side, it will change its sign to 3y. It now equals to x dividing by 3 on both sides. Y equals to 1 over 3x. So what's the gradient there? The gradient is 1 over 3. What number can I multiply 1 over 3 with to get negative 1? So it's the negative reciprocal of that. Negative flipped that fraction. If we find the reciprocal of 1 over 3, it's 3 over 1, and 3 over 1 is equals to 3. So the gradient is actually equals to negative 3, and then the point in this case is negative 2, 2. Let's find the equation. Y minus y1 is equals to m into x minus x1. Now let's try to substitute here. Y minus 2 is actually equals to the gradient negative 3 into x minus negative 2. Now let's simplify here. So we'll move the 2 to the other side, and then you have your y is equals to negative 3x. And then negative 3 times negative into negative 2, that will is going to give you a negative 6. And then remember that we have transposed that to the other side, so it's going to be a plus 2. And then simplifying that, y is equals to negative 3x, then minus 4. Let's go to an examination question to try to apply our knowledge. Now this was 2023 final examination paper 3. This is the kind of question we have here. try to play around with this question. You are given this diagram. As you can see, this is your K and that's your 4. And then what does this question say? It says that the gradient of L is minus 3 on 4. Find the value of K. So if this is minus 3 on 4, this is 4, 0, and that's K, that's 0K. So this point here is the y-intercept. So it's 0, K. And this point here is 4, 0. It's actually the x-intercept. Finding the gradient rise over run, which is the y2 minus y1 all over x2 minus x1. And this is equals to, what is y2? I can call it k minus 0 divided by the 0 minus 4. And this should give me 3 over negative 4. Let's try to deal with this one here. Let's try to deal with this stuff here and try to find the value of k. So from there, k minus 0 is actually k. This is actually k divided by 0 minus 4 is actually negative 4. And this is equals to 3 over negative 4. And then on the bottom, on the denominators, we put negative 4. And then on the, if these two fractions are equal, once the denominators are the same, then the numerators must also be the same, which simply tells us that the value of k is actually 3. Now, here is the question. What does this mean? Another line S perpendicular to L passing through 0, 1.5. Which means we have a line which is actually perpendicular to the given line here. And we are told that it's passing through this point. Like that. There's the line. This line is now L. This is line L. And then you are told that it passes through. Find its equation. Then what's the equation of this line? It's passing through 1.5 here, 0.1, and it's perpendicular to. So what's the gradient of that line? First things first, the gradient of this line is going to be the negative reciprocal of this one here. That's the gradient of the perpendicular. So the negative reciprocal of that is actually a positive 4 over 3. And so the equation of the line is going to be y is equals to 4 over 3 x. And then it is the plus 1.5, where your 1.5 is nothing but the y-intercept. Thank you for staying tuned into this video. Stay tuned for more.